Hello, my name's Keith Rucker. Got another little project we're working on out here today at the Georgia Museum of Agriculture. Still again on the J. Vance Planer matcher restoration that I've been working on for some time. The part you see over here on the lathe is one of the feed rollers that is on this big planer matcher that we're working on. There's 4 of these total. And the way these work, there's 2 rollers that are on top of one another. They're both rotating, and it grabs a board and it pulls it through and keeps it at a certain height and gives it the friction needed to pull over the cutter heads in this machine. And obviously, this being a 100-year-old machine, these are old. They're pretty worn. They've been out in the rain and the weather for quite a while. So the project today is to kind of get this thing refurbished. This is the last of the 4. 2 of them are already back on the machine. One of them, the pair to this one, the bottom one of this will be the top feed roller on the outfeed side. The bottom one I've already got pretty much done. I did those months and months ago actually, but had one left over to do, so that's what we're going to be working on today. Just so you know how this is made, there's a steel shaft. Actually, there's 2 steel shafts, one on each side, that goes into the roller section here. The roller section is cast iron. It's hollow on the inside, so it was a cord pattern originally. And these shafts come out of each end, and they're basically just keyed in. It's a pretty tight press fit. I'm not sure exactly how that's mounted in there, but I know it's in there real well. But I can actually look in the little holes here on the ends, and you can see the shaft does not go all the way through. It's just sticking out from each end. But there's a pretty good chunk of cast iron on each end that is pressed up into. And again, it's keyed somehow. I'm not exactly sure how, but I'm pretty sure that's keyed in there as well, so it won't rotate or won't spin. So we got a couple of things we need to do on this to get it trued up. The first thing is on right here, this section, and on the section on the back is be the bearing journal that will fit up into the bearing blocks. They'll have bronze bushings in them. So these are pretty rough. Not really rough, but rusted, which makes them rough. But you still got a pretty good machine surface on most of them. But on the bottom, particularly on this side, there's a lot of pitting from where it had just gotten rusty over the years. This side over here is not terrible. There's some roughness on it, but it's not terrible. This end down here is pretty bad. So we're going to just take that up, true that up. It's going to be turned down. I'm probably going to have to take a 100 thousandths off of this end to get it trued up. Maybe not quite so much on this end, but we'll get those cleaned up, get them polished out, and then of course we will turn the bushings that will go on the bearing blocks to match whatever diameter I end up on these. And the diameter really isn't critical. I think on the other ones I tried to get them at 1.5 inches and was able to get them all at 1.5 inches, and that's just what I turned them to. I'll do the same thing here, but I'm a little worried this one may not clean up at 1.5 inches. We may have to go a little bit more. We'll just have to see when we get in there. The other side I'll probably just turn to 1.5 inches just to keep them all standard. So we'll have to get that done. And also the cast iron part here, this too has got some pitting on it. It's fairly rusted up. And I know from doing the other ones, this was a machine that was made to do rough lumber, and you have pretty common sizes of lumber that went through this machine over the years. There's probably millions of board feet ran through this machine when it was in operation. But what I have seen on the other ones is that about 4 inches over on this side it's worn. Then at 6 inches it's worn at another level, and then at 8 inches it's just kind of stair-stepped, and that's because you have 4-inch lumber, 6-inch lumber, 8-inch lumber, etc. And as the 4-inch side is smaller, and it just gets larger as you go across. So we've got to get this trued up all the way across. Again, I've already done the other 3. It is important that this diameter match the other diameters of the other feed rollers pretty close. And the reason is that these 2 rollers are geared to one another, and they're rotating at the same RPMs. And you want the feed, you want the travel, how many feet per minute on the surface of this roller to be the same on the top and bottom, and also to be the same on the other one so that the board is feeding through at the same rate. If the diameters are off because they're turning at the same speed, one roller will actually have a higher inches per minute or feet per minute on the surface of the diameter, so they need to match, and I'll need to go remeasure that and figure out what that is, and that's what we'll turn this down to. So anyway, we've got this set up on the lathe. I don't have it trued in. I've got a 4-jaw chuck on this end. I've actually got a good surface right here. A little gear went right here next to where on the chuck end that drives this whole roller. And when I press that off, I still had a real good machine surface under there. So we're going to indicate off of this, get this end set up running true, and then we've just got a center on the back side. And I was able to come in, it had centers on both sides, and I was able to just go in there and clean that center up. So I've got it running off the center on the back side. And one of the first things we'll need to check is to make sure everything is running pretty true. I had a problem on one of the rollers before where the shaft was actually bent a little bit on the large gear that went on it, where it had just been stressed, probably when the gear was broken in the earlier part. It put some stress on there and caused that to bend, and we had to take care of that, address that. That's all been done, but I do want to make sure everything's running true. I suspect this one's going to be okay. The one that gave me the problem was the driven gear, whereas this one is not a driven gear. It doesn't have the big gear on the end. It's actually being powered by the smaller gear on the other end. So I don't suspect that we'll have that problem, but we'll need to check that out. I will note that the overall length of this is about 40 inches, and I'm fortunate to have a real long bed on this Lodge Shipley lathe that we use. I've got a 10-foot bed on here, and if you're turning between centers and using the tailstock, you can easily turn something 8 foot long on this lathe. Actually a little more than that, the way it's all set up. But I've got a 10-foot bed on here. I'm using about 40 inches now. So it's nice to have that capacity on a big lathe like this. You know, 95% of my work is right here in this small area down here, but when this job comes in that you need to have that length, it's really nice to have that capability. So enough talking. We're going to come in here and get started. We'll indicate here and get this trued up, see what we run into, and get started on this job. We have the work set up in the 4-jaw chuck, and the task now is to get this thing running true. And I'm going to show you again my indicating method of how I go about doing this. When I'm indicating in a 4-jaw chuck to get things lined up, I treat it like it's an XY axis, similar to like if you were working on a milling machine where we're going to be moving the part in 2 axes. But instead of having a crank to crank up a milling machine table, in this case I've got jaws that I have to loosen and tighten to accomplish the same thing. But the goal here is we're going to move it left and right, up and down in these 2 axes to get it running right on center, and we'll use the indicator to do that with. I've got the indicator set running straight across, so I'm always going to be adjusting in this axis going here, and I can rotate my chuck to determine which jaws I'm going to be working off of any time. So we've got it in here. Step number 1 is to kind of just look at it and figure out which axis you want to work on first. I usually start with the one that's the worst out, the farthest out, and get it moved in, and then we'll work on the other one. If things are way out, I may kind of get one a little bit closer and then go to the other, get a little bit closer. I like to get both of them running within 100 thousandths before I really get serious about it, but just because I can see the entire range of movement in one pass on the indicator, which is 100 thousandths on this indicator here that I'm working with here. So once I've got it kind of there, then we start trying to dial things in. So what I've done now is I've got my jaws numbered. This is 3 and 1 is directly across from it. They're both odd numbers. My other one is 2 and 4. They're even numbers. So if I look at 3, I know I got to go to 1. I just took a Sharpie pen, wrote it on the jaw so I can easily see which one I'm working with. And I find the high spot. So I'm on 3. This is the high spot. I zero my indicator. I then go over here to 1. I'm going to look at it real quick, and we're about 90 thousandths, a little less than 90 thousandths, actually about 85 thousandths out. So I'm going to go back over here to my high spot on 3, and I'm going to loosen this jaw over here just a little bit. All right, then I'm going to go back over here to my low spot right here, and I'm going to move it over by pushing in here, and I'm going to look on my indicator to see how much I've gone. So when I loosen that up, now I'm about 80 thousandths. And you know, to start with on rough movements, I know where my zero is, I know here, and I'm just going to try to split the difference, okay? I'm not trying to get it super accurate, I'm just trying to get it close right now. So I'm just going to visually split the difference of that angle, which is going to be somewhere right along in here, and I'm going to try to move it all that way. Now, I may have to do this multiple times because I don't want to loosen up the other side too much on any one pass, but we will see what we can get out of this one. We may have to do it again. So I tighten that up, and I was only able to move it about 5 or 6 thousandths, and that's fine. Okay, so now I'm going to come over here. I'll put that on 0, sweep back around. Whoops, went the wrong way. But that's okay. And you know, we're at about 60 thousandths now. So again, this is my high spot. Let me set my 0 here. I'm going to loosen this jaw up again just a little bit. We'll go back across over here to number 1, and again I'm just going to try to split that difference, and we've made a little more progress. 0. I'll loosen this up, go across. Okay, we're getting close now to being on that one, and it's not perfect. We're still, let's measure it and see where we're at. So there's 0, and we're about 7 thousandths out. Okay, now what I want to do is I want to check my other 2. So I'm going to look on this one. That's a 0. Come around here to 4. And we're also about 7 thousandths out. So let me come back over here. I'm going to loosen this one just a little bit. And same thing. Now I'm getting down to the point where I'm going to pay attention. I'm 7 thousandths, so I'm really only trying to move it 3.5 thousandths, which is about right there. So let me 0 that. We'll check number 2. Go this way. And okay, I'm within about 0.5 thousandth, maybe just a little bit more than that. Let's go back to 1 and 3. So we're on 3. Let's just first see how much we got to go. And now we're at about 7 thousandths again. Come over here. Loosen this one just a little bit, not a lot. I'm not going a long way. And that moved it to about 5 now. So we'll go about 2.5. That's getting real close. Let's see where we're at. So all I'm really seeing is just the, you know, indicator. It may be off by a few tenths, but plenty within tolerance for what we're looking at here. So it takes a little bit of trial and error, just a little bit of work, a little bit of fiddling. Once you do this a few times, it kind of becomes second nature, and it's fairly easy to dial something in on a 4-jaw chuck with a good indicator. So we've got this roller here lined up on the other end, and just so you know, off camera, I came down here with the indicator and I indicated on this end, and I do have a little bit of run out, about 15 thousandths down here, and that's probably from where this shaft isn't just perfectly straight. I decided I'm just going to go with it like it is. I know I'm going to have to take more than that to get this cleaned up anyway, so we're just going to basically turn that run out will be the plan here. And I will also just tell you before we get started on this that based on my experience on the other ones that I've already done, because we are turning such a long shaft here, we had some chatter issues. So I'm going to be taking some fairly light cuts down here, at least to start with, seeing what kind of finish we're getting. We may have to put the steady rest on the main part, on the larger part, to give us a little more rigidity in there. But we're just going to start out easy and see where we're at and adjust as necessary as we go. So let's get started here. Well, we've got some differences in the finish down here. I don't think I'm getting a lot of chatter. I think what's mainly happening here is that this shaft ran in that cast iron bearing for years and years, and I think it's gotten hot at one time or another, and I think what you're actually seeing in the surface finish is just a difference in the hardness going across that shaft, where we got some work hardening going on. So that was just about a light pass that we took there. I took about 20 thousandths, and I was indicating right in here, and I see we cleaned up in there, but we got a little bit more in here where it didn't clean up. So, but that's fine. We've got plenty of material to work with here. I'm going to take another light pass and just work this down to about 1.5 inches. On that pass, we cleaned everything up, and it's measuring about 1 inch, 650 thousandths. I want to get it down to 1.5 inches, so I got 150 thousandths to cut off. Those last two passes were about 10 thousandths cuts each, so we've removed a total of about 40 thousandths of material, and we're going to take a little heavier cut this time and get us on down there where we need to be. Sorry about that. I had someone come in and was chatting to me, and anyway, the camera got turned off, and I took a couple passes there. The last two passes I took were I was removing a total of 60 thousandths per pass, so 30 thousandths cut. I'm now right down on there, and we're going to do just a real light skim pass. I think I got about 2-3 thousandths to go to get to where I'm at. I'm going to get my mic, double check that, and this will be my final pass to clean this up. I got about 2 thousandths I need to take off of this to be on my final diameter, so we're just going to take a real light final pass and we'll call this job done, or this part of the job. Right where I want to be. I was shooting for just a little under 1.5 inches there. I'm going to ream my bronze bushing out to exactly 1.5 inches. So I'm actually turning this about 4 or 5 thousandths under that diameter. So we're right on the money. A couple of comments here. On that last final pass, I got a little bit of chatter in there. Chatter is a problem you run into on lathes a lot of times, and it has to do with vibration and the harmonics of what you're dealing with. And again, having done the other feed rollers, I had some chatter issues on some of those. This one turned out pretty well, and it wasn't really until that last real light pass that I had some issues. And that's something to keep in mind if you ever run into a lathe problem where you're getting some chatter. A lot of times you can actually solve your chatter problem by playing around with your speeds and feeds, and particularly your feeds. If you'll take a little bit coarser cut, a lot of times it'll solve your chatter problem. And I've got this set up taking a fairly light cut. Same thing with your speeds. It has really more to do with the harmonics of the rotating shaft on a long shaft, and things being a little bit out of balance. And sometimes by just playing around with, again, those speeds and feeds, you can fix that. There's a little bit of chatter in there, but it's not bad at all. What I plan on doing here is I will come in after I get through everything. We're going to polish these journals up with some emery cloth, and we'll be just fine there. I'll be able to polish that little bit of chatter that was in that 2 thousandths cut out without any problem. So this journal is right on the money. So we're going to go over and we'll set up and we'll get the journal on the other side and do it basically the same way. We're on the other shaft, or the side of the shaft now, or the other journal. If you notice, I've had to kind of get a little odd setup here to make this work out. I really want to turn both of these journals on the same setup without taking out the lathe, so that they are exactly in the same axis to one another. But because of how this is, and I'm going into that shoulder, I'm going to have to turn my part opposite. So instead of feeding the carriage toward the chuck, I'm going to have to feed the carriage away from the chuck and into the shoulder. So I have a left-hand bit in here, and also because of how this overhang is, we had to kind of cock the compound a little bit and do some funky things. But I got everything where it should work. I've checked to make sure I got clearance in every direction. So we should be ready to go now to turn this journal, and we're going to do the same thing, take it down to 1.5 inches. All right, just a couple of comments here. I was having some issues with some pretty nasty chatter on this end, so I played around with a couple of things. First thing I did was I put a steady rest down here on the back side on the second part that I had just turned, and that seems to be helping a lot to kind of take some of that vibration out. Again, the chatter is really caused by the harmonic vibration in this long piece. I've got a cast iron part here. It's not balanced, and as it's spinning, you just get some vibration. Another thing I did was I sped my feet up just a little bit, but probably the thing that made the biggest difference is when I changed tools over here and I went to a left-hand or right-hand turning tool. It had a different insert in it than the one I was using before, and a different grade or different type of insert. I swapped those out, put the same type of insert in that I've been using on the other side, and that seemed to have made the biggest difference. So it's doing a lot better now. That's not completely cleaned up, but it's getting close. Let me get a measurement, rough measurement on this, and we're at about 1 inch 625 thousandths. So we got about 125 to go, and we'll finish this out. Yeah, I'm real happy with that. Great finish on this one. Man, what a beautiful, couldn't ask for a prettier finish there. I made about a 25 thousandths cut, 50 thousandths total removal on the pass before this, and I saw that great finish, and I said, I'm just going to shoot for the moon and take that heavier cut, which I think helped on the chatter a little bit. And we're right there on money where we need to be, and that journal is nice. All right, we're down to turning the cast iron part now. I've slowed my lathe down a little bit. We're just going to see where we're at, see what it takes. We need to take about 100 thousandths total, roughly, off of this. It's such a rough finish, it's hard to get a good measurement of where we're starting from. So we'll just go in here and see what we end up with. We may have to make some adjustments depending on how much chatter we get on the cast iron part here. So we're about through with this. It was taking a while to get that long cut. Had to slow it down because of the RPMs or because of the size of this, and to get a chatter-free cut. It's taking about 30 minutes to cut that pass. But we've got it down to diameter. There's still a little bit of pitting in here showing, but really if you look at it close, you got good surface contact all the way around. So I'm not going to try to take it off. We're going to leave that just like it is and just call it good enough. I will just make one other comment about chattering. Again, on this lathe, or not on this lathe, but with this part, this is a cored out piece of cast iron here, so the thickness inside of this varies somewhat, and the bottom line is it's just not balanced. And when you start getting it up at the higher speeds, it's just like if you have a tire on your car, that if you ever had one that's get out of balance, you know, you get that vibration in that wheel, and you may even notice that if you ever get a tire out of balance on a car, that at certain speeds the vibration is worse than others. Or another analogy that you can think of is a grinding wheel on a grinder. If that grinding wheel is just a little bit out of balance at certain RPMs, it will really vibrate. So if you ever turn on your grinder and shut it down and it's winding down and it gets to a certain speed, and all of a sudden the whole grinder just starts shaking, and then it gets to another speed and it stops. Well, the same thing's going on with this part here. Because this piece is not balanced at the high speeds that we were turning it, we were just getting some vibration in there, which we were able to resolve with this piece by slowing it down because of the balance problem. On the machine, this is turning real slow. I mean, it may be turning 30 RPMs at full speed. So, you know, balance isn't going to be an issue in operation, but working it on the lathe, it definitely was an issue throughout, and we've dealt with that on every one of these. So we're pretty much done now. All I'm going to do is I'm going to get my lathe cleaned up. When you're turning cast iron, you get this real fine chip, and you know, be real careful with this on your lathe. You don't want this stuff to get all over the place. You don't want to let it get in your ways and up into your machine, because this stuff, it acts just like sandpaper. It's like grit. So anytime I do this, the first thing I'll do when I get through is I'm going to clean everything real good. I will use a brush. I will brush it off. I laid some towels on here to try to catch most of it, but I'm going to brush everything down. Try not to use the compressed air on this kind of stuff in particular. You know, a chip like this, while it can get up into some bad places and cause you some problems, you're much less likely to get a problem with that than you are with this fine dust. So we're going to make sure we get this cleaned up real good. Once that's done, I'm going to come in here with some emery cloth and just polish these journals, and I'll do that off camera, and this part right here will be done and ready to go. So there we go. We're going to call this job done.